Hello ladies and gentlemen, welcome to the latest of the Math 12R screencast lessons. The lesson today is how to solve a system of three equations with three variables. So we've been working with two equations and two variables, x and y. Well, we're going to add a z to it now. The method that you use to solve a system of three equations with three variables is repeated elimination. So we've been using elimination. We also used substitution. We won't be using substitution here. This process is a series of elimination steps. Okay, so if you look at the example you have, page 1 of your handout, by the way, is a whole bunch of typewritten words, and it's the step-by-step instructions. So instead of me reading you the instructions, I'm just going to go right to solving the steps of how to solve. So the first thing you want to do is look at the three equations, and you've got to eliminate the same variable. So you have to pair them up, and I paired them this way. The first equation and the second right here. Then I paired the first and the third here. Okay. My thought was to eliminate the x's. So I started here. This is a 2x, that's a positive x. In order to add the equations together and have them cancel out, one of them has to be a negative 2x. So I multiplied the first equation here by negative 2. Negative 2x plus 4y minus 2z equals negative 30. And I just carried this second equation over. When I added them together, the x's dropped out. I did a similar thing on with the other pair. You've got to create two pairs of equations. Obviously, you have to use one of the equations twice. So on this second pairing, I multiplied everything by negative 4 because negative 4x plus 4x is 0. And again, I want the x's to drop. You need to make sure that when you pair them up and you work on them, you're eliminating the same variable both times. So when I add them together, this first pairing gives me 7y minus 5z equals negative 29. The second pairing gives me 18y minus 9z equals negative 63. So now I have two equations with two variables. So I carry them down, and I look at this, and I said to myself, if I wanted to eliminate a variable, what would be an easy thing to do? 9 times 5 is 45. 7 and 18, the numbers to make the y's drop out are a lot bigger. So I opted to drop out the z's. And I opted to take the top equation and multiply by negative 9. So the signs will all flip. And multiply the bottom equation by 5. So the first equation multiplied by negative 9 is negative 63y plus 45z equals 261. Second equation multiplied by 5, 90y minus 45z equals negative 315. So now I add those equations together, and the z's drop out, which is what I wanted. So 27y equals negative 54, y equals negative 2. Okay, so now I have a value for y. I'm going to go back to one of these two original equations here. Right? So I have to go one level up from here, pick one of them, and find z, which is what I did on the left. Over here, I use the 18y minus 9z equals negative 63. The negative 2 goes in for y. And I solved that. I found out z was 3. Alright, so now we're moving along. We know what y is. We know what z is. So then I chose one of the other original equations. I chose the third one, 4x plus 10y minus 5z equals negative 3. I substituted the negative 2 for the y, 3 for the z, solved it, and found out that x was 8. So when you write your answer, you have to write it as x comma y comma z. What you need to do now is make sure that those three values of x, y, and z work in all three of the original equations. So I start out with the first equation. 8 goes in for x, negative 2 for y, 3 for z. 8 plus 4 is 12, plus 3 is 15. So those three values check out in the first equation. So then I come down to the second equation. 2x plus 3y minus 3z equals 1. Again, 8 in for x, negative 2 for y, 3 for z. 16 minus 6 is 10. 10 minus 9 is 1. They work in that equation. Now I check all three values in the last equation. So there's the equation. Substitute the 8 for the x, negative 2 for the y, 3 for the z. 32 minus 20 is 12. 12 minus 15 is negative 3. So these values work in all three equations. So if you need to go back and replay this, that's fine. All you're doing, and don't make it more complex than it really is, all we're doing is repeated elimination. So let's go back and review. I look at my three original equations and I decide that it might be easier to make the x's drop. So I pair them up. I paired the first two equations here, and over here I paired the first and the third equation. By multiplying on the left here by negative 2, I make the x's drop. By multiplying the first equation on the right side by negative 4, it again makes the x's drop, and that's your goal. I want to eliminate the x's on both sets in the first pairing. Here's the first pairing, these two and these two. So don't work on this one and let the x's drop out. Don't let the y's drop out here, because you won't have two equations with the same two variables in them. So you need to be thoughtful about how you begin the process. And then now you have two equations, two variables, and that's what we did last week. So you solve that, you get a value for one of the variables. I go back to one of these two equations here, put the value of negative 2 in for y. I find out that z is 3. Now I have two of the three variables. Then I pick one of my original three equations, substituted the negative 2 for y, 3 for z, solved it, found out that x was 8. I wrote my answer, my solution, as an ordered triple, x comma y comma z. Then, just to make sure that my work was right, I did a check, and I start all three original equations, and I substituted the values of x, y, and z in them, and they all worked. So in class we'll be doing several more of these problems. Thank you for tuning into this latest edition of Math 12R Lessons. Again, this lesson was brought to you directly from my dining room table.